So in this episode of Reel to Real, we are going to make this reel into a real project. Let's have a look.
Show me this. Show me this.
Show it to you?
What does it do?
So in this reel, the person shows that the bulb attached to the respective switch turns on whenever the switch is pressed. But when he changes the cap of those switches, in that case as well, the bulb with the same color as that of the caps turns on.
The yellow lights the yellow, and the green lights the green.
Seems magical, right? Well, first of all, let me tell you that this reel is totally a fake project. Let's observe it carefully.
Green.
And then with the red here. And somehow...
So at this moment, we are able to see a cut in the video, and during that cut, they may have changed the wiring or coding to make this project work accordingly. So now the question is, if this is the fake project, how we are going to turn into a reality? Well, let me tell you, like all of us, as I watched this reel for the very first time, I was totally surprised and I was thinking the way like how this project can be made in real. I even asked this question on my social media, and most of the people told me that there must be some kind of color sensor attached onto the cap which can sense the color, and accordingly we are able to turn on or off the light. Well, attaching a color sensor with the cap according to me seems not at all possible. So while thinking, I got an idea to make this project turn into reality. So first of all, let me discuss that plan with you. So first of all, we won't be using the real knife switch, rather we'll be getting everything 3D printed. But why 3D printed? Well, let me explain. So here the major challenge is we need to sense the cap anyhow, and for sensing the cap, what I did is I got a 3D printed cap and I have attached two tiny sensors, one in the front and other in the back side of the cap. So we are having two different magnets in the 3D printed cap, and now what we did in the pole side is we have a hollow pole 3D printed, and the top of the pole we have two Hall sensor, one in the front and one in the back. So with this Hall sensor we'll be able to sense the magnetic pole of the magnets, whether it's a north pole or a south pole, and with the help of two Hall sensors data we can easily recognize up to 4 different caps according to this combination. So we have north and north, we have north and south, south and north, and south and south. Okay, so the sensing part is pretty much clear. So we'll be using a magnets and a Hall sensor to identify which cap is inserted. Now the question is, as this is a 3D printed switch, how it will be able to carry the current, like how we'll be able to sense whether the switch is pressed or not. So for that, what we did here is we have attached a tiny little limit switch near to the hinge of our 3D printed knife switch. So what will happen, as soon as the knife switch is pressed, it will push the limit switch and will be getting a signal, and whenever the lever is pulled up, the switch will be released and we'll be getting the signal for that as well. Okay, so the switch part is also sorted. Okay, so all the data of the switch, the magnet and Hall sensor will be given to a microcontroller which will be having some logic in it, and according to the logic we'll be able to turn on and off the particular color LED. So that's the complete plan. Now let's see if this theory can help us to make a complete real project or not. So what I'll do, I'll grab all the components required for this project, and till then you enjoy this informative ad. This video is sponsored by Altium, and they came up with an amazing product called as Altium 365. So Altium 365 is an electronics product design platform that unites PCB design, MCAD, data management and teamwork. So with Altium 365 you can do the PCB designing task, you can share your projects over web for review purposes. It do cover sharing your PCB file to mechanical team so that they can create the mechanical product package based on your PCB. Then it also provides centralized cloud storage, so you don't need to rely on one single computer for your files. It also helps you with managing your components and get real-time supply chain data for your components. It also allows multiple people to work on single project. And in the end, it also helps you with sending your design to final manufacturing units. So Altium 365 takes care of all other tasks, so you put more time and effort in making something creative and useful. And the good part is you can try out its free version as well. I'll leave its free trial version link down in the description of this video, so do check that out. And now let us start with this video. So on the electronic side, we'll need a microcontroller. So here I'm using an ESP32 board, but you can use any microcontroller of your choice. Then we'll need a couple of Hall sensors, limit switches, and couple of AA batteries to power it up. Now on the 3D printed side, we need 4 sets of poles, hinge and a cap. Well, this is a hollow pole with enough space for attaching hall sensors in it. So after getting them all, we first attached the hall sensors in the pole and all the wires were taken from the bottom side. After that, we attached a limit switch at the hinge portion, and after doing this, we need to attach all the modules on the base. And for that, we got this acrylic base with proper slots and holes on it. So we one by one started inserting all the 3D printed knife switches in it, and after inserting them all, it looks something like this. Then we mentioned the poles of the magnet, whether it's a north pole or a south pole, and after that, one by one we started sticking them on the respective cap according to the combination that we have discussed before. After doing that, we stick different color LEDs onto the base, same as of the color of our caps. After that, we made a PCB with the main controller and couple of connectors for switches, sensors and LEDs. Then we made the connections of all the peripherals at the respective ports and we attached a switch as well to turn on and off the project. Then we wrote a simple code for our ESP32 board that contains the logic for turning on and off the LED based upon the magnetic poles sensed by the hall sensor. And after confirming the code, we uploaded it on our ESP32 board. In the end, we covered the back with an MDF shade and finally our complete project looks like this. Now let me show you it's working. So now let's have a look over the demo of our magical project, okay? So as of now, all the switches are in off position and all the caps are in the sequence of the same color LEDs, okay? So if I close this switch, the red LED turns on as the red cap is attached here. The green turns on as the green cap is attached here. The blue and last the white, okay? So this was a simple demo of turning on the LED based upon the same switch in front of it, but now the magic starts, okay? So I'll turn off all the switches, I'll remove all the caps, okay? Let's just remove all the caps and now I'll randomly interchange the caps. So red will go to this one, the white to, let's say, this one, the green to this and the blue to this, okay? So now the LED should turn on based upon the color of the cap, okay? So let's start with the green one, okay? And yes, the green LED turns on, and similarly if I turn on the blue one, the blue turns on, the white one, then white turns on, and the red one, then the red turns on. So this is the magical project which was earlier a fake video, but we turned into reality by doing some R&D and adding our own creativity and logics in it, and we turned this fake project into a real project. How was this project according to you? Do let me know in the comments of the video. And also, if you ever come across any kind of reels about projects and electronic gadgets and everything, do share that with us on Instagram, which goes by the name techiesms, and our team will try to reverse engineer that, and maybe we can turn that project into reality. So yeah, that was another episode of Reel to Real project. I hope you liked it. If it is so, click a thumbs up. And yeah, that being said, I am just ending this video here, and now just wait for my next video. Until then, explore, learn, share with me, techiesms.